Okay, Advanced Math Lesson 29. Part A is called Unit Circle, and that'll make sense in a moment. We're going to start out looking at one of our special triangles here. It's our 30, 60, 90. 1, 2, root 3. All right. The smallest side is always opposite the smallest angle, and so on. And the square root of 4 is bigger than the square root of 3. That's why 2 is the hypotenuse. Okay, anyway, if we use a scale factor of 1/2, we get this similar triangle. Okay, so basically if you take a half times all these, then you get this triangle. Half of 1 is a half of that is root 3 over 2, half of 2 is 1. Okay, those are similar triangles. The angles are still the same. When the length of the hypotenuse is 1 unit, the opposite side is the sine, and the adjacent side is the cosine. Look at this one with the numbers on it. Okay, what's the sine of 30 degrees? Take a look at our triangle. 1/2 over 1. That's a half. Okay, it's the same as what you get here because they're similar triangles. The sides are proportional. The sine of 30 is always 1/2. Okay, but the nice thing about this is that side is the sine. This side is the cosine. Okay, and that works anytime your hypotenuse is 1, because sine is opposite over hypotenuse. So it's something over 1, which means the opposite has to be the sine of that angle. And then likewise, cosine is adjacent over hypotenuse, so we have that. Adjacent over 1, so this side has to be the same as what the cosine is. All right. If we, by the way, I'm just going to label these. So this will be our y, this would be our x, and your book is using h for hypotenuse still here, but we often use an r for that, and that'll make sense in just another moment. We'll get down here to the circle. Okay, here's where triangles and circles are coming together. If we use a circle whose center is the origin, 0, 0, and whose radius is 1, like we were just talking about up here with the hypotenuse being 1, then the coordinates of the points on the circle give us the sine and cosine for any given angle. Okay, so I'm going to just lightly, okay, here's my perpendicular, there's my right triangle. This is 30 degrees. Okay, if this is a 1, then this x, cosine of 30, and this y, the y coordinate of this, is the same as that height. That would be the same as the sine. Okay, and I know the cosine of 30 degrees is root 3 over 2, and the sine of 30 degrees is 1/2. And so I can go the whole way around the circle here, and the dots are for 30, 45, and 60 degrees. Let's put the degrees out there. And as long as that radius is 1, that radius is the hypotenuse of the triangle. And so the coordinates of this point are the cosine and the sine of this angle. So if we were going to continue for the 45 degrees, that would be root 2 over 2 for both of them. (45, 90 is isosceles). And then for a 60-degree angle, these swap. The cosine of 60 is 1/2, and the sine of 60 is root 3 over 2. Okay, this isn't multiplied, I'm just labeling for a 60-degree angle there, we're here. For a 45-degree angle, we're here. The 30 was here, that one I marked in the triangle. And we can go the whole way around the circle with that, which I don't think I'm going to spend time with in the actual video. Well, maybe I better, because then we'll talk about these other quadrants. Okay, so here would also be a 30-degree angle. That means this is 150 degrees, 180 minus 30. I'll put the degrees here. This would be 180 minus 45. And then here's 180 minus 60. All right, so here we have a 30, 60, 90 again. So it's these numbers, only we know that all students take calculus, and we'll talk in a moment about that again. So I can copy these numbers, but I know the sign is positive, but the cosine is negative. And clearly, this is the negative x-axis. Okay, so this x-coordinate will be negative root 3 over 2. And the y is still a half. It's positive 1/2. Write that kind of far away. For 135, same numbers here. Our x is negative. Our y is positive. So we have negative root 2 over 2, root 2 over 2. And then for the 120, it's going to be the same absolute values here as the 60, only again, the x needs to be negative. We're on the left side here. So negative 1/2 root 3 over 2. And we could keep going around. I think you hopefully see the pattern. We already talked about all students take calculus. Tangents positive here, sine and cosine are both negative. The x-coordinate's negative. The y-coordinate's negative. So everything kind of comes together. I also wanted to mention, you know, that the coordinates of any point is x, y, which is why I was using x and y in the triangle here. This is the same number as your x-coordinate. That length is the same number as your y-coordinate. R for radius, because the hypotenuse of your triangle is the radius of the circle. Okay, so you're sometimes going to see, instead of, okay, so sine of theta is opposite over hypotenuse, but that's y over r. And cosine is x over r. That's adjacent over hypotenuse. And we should take a little bit of this space to talk about tangent. I don't want to forget to talk about that. This is a very useful property that you'll see. So let's think a moment about, I know it seems like we're totally switching gears here. We're going to do sine of theta divided by cosine of theta. It's related. Okay, and you can think about it in terms of opposite and hypotenuse or the y over r thing, but we're going to practice it with this y over r thing. Okay, so the sine is y over r. Cosine, like I said, is x over r, and you can take a look at this triangle again up here. Cosine, if this is my theta, okay, sine is y over r, cosine is x over r. And that would be y over r times the reciprocal of this one. R's cancel, and we get y over x. Y over x is tangent. Look back up at your triangle. I should have tried to keep that on the screen. Okay? Y over x is tangent. Tangent is equal to sine divided by cosine. Okay, tangent is the same as sine divided by cosine, which you'll find very useful in the future. Okay, y over x, tangent, but we started out with sine over cosine. They are equal. Okay, now, part B is about very large and very small fractions, which will help us when we get into part C. So, if the denominator of a fraction is fixed, see, we don't change the denominator. In this case, it's just staying a 4. Then as the numerator decreases, the value of the fraction decreases. So it's approaching 0. Okay, we'll start with a fairly big one. Numerator's decreasing. We see what happens to the value when we simplify them. That is also decreasing. And it won't get down to 0 until we would actually make the numerator 0. Okay, so it's approaching 0, getting smaller, smaller, and smaller until it goes down to 0. All right, and here's a graph trying to show this. The value of the fraction approaches 0 as a limit as the value of the numerator gets closer and closer to 0. So it's just restating what I just said. Okay. Now, if the value of the numerator is fixed, then as the denominator decreases, the value of the fraction gets larger and larger. Okay, and that top graph is like as you're getting closer and closer to 0, your y is approaching 0. This graph, I'll try to explain better as we're looking at this. Okay, so we're keeping the numerator the same this time and making the denominator smaller and smaller. Okay, your value is getting larger and larger. And here, this is one of those reciprocal functions. Okay, so as you're getting in here for your x being the denominator, closer and closer to 0, it's approaching infinity. It's swooping up or way down after coming from the negative side. Okay, so as your positive number is decreasing and decreasing, getting closer to 0, the value of the entire fraction is approaching positive infinity. And if you're using negatives, but you're getting closer and closer to 0, then you'd be approaching negative infinity. The numbers just keep getting, the absolute value keeps getting larger and larger, but they're negative. Okay. Just a concept to keep in mind while we're talking about quadrantal angles. Okay, so quadrantal angles are angles whose terminal side is on an axis. Okay, the initial side, we always start on the positive x-axis. The terminal side is the other ray of the angle. It's often what we draw into one of the quadrants. But on these quadrantals, the other side isn't in a quadrant, it's on an axis. So these are angles that are multiples of 90. 0, 90, 180, 270, 360 comes back around to being the same as 0. Okay, so we can't exactly use triangles if we don't have a hypotenuse coming out into a quadrant somewhere. Okay, so what we're going to think about, though, is a collapsing triangle for just a moment. And that's what this is trying to get at. Okay, trig functions of quadrantals are defined to be the limit approached by the trig functions as that angle gets closer and closer to the zeros, to 0 or to 90 and so on. And that's why we had part B, thinking about what happens as something's getting closer and closer to a number as it's approaching it. And the whole idea of collapsing triangles, let's take a look at that. Okay, so let's go up here. So here I have my x and y axis, and this will be my hypotenuse. Okay, this is my R. All right, so I'm here, and that's a fairly large, it's not 90, but maybe it's 80, okay? And as my angle is getting lower and lower and lower, okay, if I'm keeping the same hypotenuse, this might be harder. Let me show you on here instead. Okay, here would be a very large, maybe 88 degrees or something. And so I'd have a very tall, skinny triangle, right? My x is very small, so cosine is very small. My y is very large, so the sine would be very large. And as this is dropping down, we're just going to go right to left here. As this is dropping down, now the y is smaller, but the x is bigger. Here the y is even smaller, but the x is even bigger. Same here. And if this fell flat, okay, what was the hypotenuse will be the same as my x here, which is the cosine. And there'd be nothing here, no gap there. The y, that side of the triangle, would no longer be a side, it would be 0. Y would be 0. Okay? And so up here, that's what this is showing. The coordinates of this are r0. The x is the same as the hypotenuse. Remember, r was the hypotenuse of the triangle in part A. And then here, whenever it's at 90 degrees, so it's here, and now the x is 0, and the hypotenuse and the opposite side are the same. They're both r. 180 is like 0, only it's on the negative side, and 270 is like 90, only it's on the negative part of the y-axis. So, for sine of 0, okay, sine is y over r, and so that's 0 over r, which is 0. Cosine of 0 degrees, okay, that's x over r. Well, the x is r. R over r is 1. For all of these, you're either getting 0, 1, or negative 1. Okay, so here's sine 90, cosine 90. Okay, so the sine of 90, sine is y over r. The y is r, and r is r. R over r equals 1. Okay, cosine is x over r. Our x is 0. So the cosine is 0. Whoops, why did I write cosine first? Okay, so sine 180, cosine 180. We're over here. Sine is y over r, that's 0. Cosine is x over r. Well, x is negative r, so negative r over r is negative 1. You kind of see a pattern. I'm going to do this on the other side where I have more room. Okay, sine 270, cosine 270. Okay, sine is y over r, negative r over r, that's negative 1. Cosine is x over r, the x is 0. See, 0, 1, go 180 degrees, you have 0, negative 1. For 90, we have 1, 0. Go over here to 270, negative 1, 0. So when you're evaluating quadrantals, those are the numbers. Now, let's use this for an example down here. Okay, draw figures as necessary to find tangent of 3 times tangent of 180. So it's 3 times, what's the tangent of 180? Okay, well, I have them right up here for now. So 180, tangent, we found out, that's why we knew that before, was y over x. Okay, here's 180. There are the coordinates, y over x. Y over x is 0 over negative r is 0. So 0. Okay. The tangent of 180 is 0, so 3 times 0. All right. Draw figures is necessary to find these. These are both using 270, and I will draw it so I don't have to keep moving off screen. Okay, so 270 is down here, and from up above we know this coordinate would be 0, negative r. Okay, so 4 times. Sine is y over r. Y is negative r. And it's over r, so negative 1. And then we just multiply, so negative 4. That was part A. And then for part B, we're doing 3 times the tangent. Okay, tangent is y over x. So y over x, we're something over 0. It's undefined. That's it. Okay, can't divide by 0. Okay, now, this one's more normal. Negative 135 degrees. Negative means we're going positive. Here's 90, here's 180. It's over here. Okay, if that's 135, this is 45. It's 45, 45, 90. Negative x-axis, negative y-axis, so those are negative. Okay, sine of that. Sine, opposite over hypotenuse, or y over r. So negative 1 over root 2, which we'll need to simplify, plus 3 root 2 times cosine of 180. Okay, so 180 is over here. My x is negative r, my y is 0, right, that's that point. So the cosine is x over r. X is this, so negative r over r is negative 1. Okay, now this one needs simplified. So I have negative root 2 over 2 minus 3 root 2. These are both root 2's. They are like terms. They need common denominators. So I'm going to, multiply by 2 over 2. I didn't give myself a lot of room here. Okay, so I have negative root 2 minus 6 root 2 all over 2, which would be negative 7 root 2 over 2. Sorry, I should have made my drawings somewhere else. But that's the answer. And that was the last example. It might take a little getting used to, but I think you're going to like these. I hope you do.